Hey there. Today, I'm breaking down one of the most useful and honestly most misunderstood tools in machine learning, the confusion matrix. If you're diving into data science, you're going to bump into this one a lot. So let's make sure it's not so confusing after all. Picture this. You've trained a model to spot spam emails. How do you know if it's actually doing a good job? That's where the confusion matrix comes in. It's a simple table that compares what your model predicted against what was actually true. Think of it as a scoreboard, but instead of touchdowns, we're keeping track of right and wrong guesses. Here's how it works. The confusion matrix is usually a 2x2 grid. On one side, you've got the actual results, what's really happening. On the other, the predictions from your model. Let's break down the 4 key boxes. First up, true positives. This is when your model gets it right and predicts something as positive when it actually is. Like catching a real spam email. Nice job, model. Next, true negatives. Here, your model correctly predicts a negative, so a legit email stays safe in your inbox. Also good. Now let's look at the mistakes. False positives, also called type 1 errors, happen when your model thinks something is positive, but it's not. That's when your friend's email about their cat ends up in spam. And then there's false negatives, or type 2 errors. That's when your model misses something important, like letting a spam email slip through to your inbox. By counting up each of these, you can see exactly how your model is performing. Maybe it's great at catching spam, but sometimes it's too aggressive and filters out normal emails. Or maybe it's missing too many spams, letting them sneak through. This table doesn't just spit out one accuracy number. It tells you where your model is winning and where it's dropping the ball. For example, in medicine, a high number of false negatives can be dangerous. You don't want to miss a real case. In other settings, too many false positives can get annoying, like when important messages go to spam. So next time you're looking at a model's results, dive into that confusion matrix. It's your map to understanding what's really going on under the hood. And the best part? Once you get the hang of it, it's not so confusing after all. Thanks for watching.